Hello and welcome to Database Mirroring. My name is Steve Hamilton. If you have any questions or comments, please feel free to use the question comment box found below. Okay, let's get started. In this module, we will learn about implementing database mirroring. This is one step into implementing the overall high availability processes within SQL Server 2008. There are several ways to implement replication as well as high availability. One happens to be database mirroring, the other one is replication, and the other one is log shipping, and we will discuss those methods in later courses. We're also going to learn how to implement a SQL Server clustered instance. And at the very end, we will provide a lab to create a database mirror. The whole point of this particular module is to look at the high availability capabilities within SQL Server 2008. Our goal as a DBA is to keep our databases up and running 24/7, 365, or at the very least, to meet our organizational needs. The last thing that the DBA wants to do is be in a position where the database goes down at 2 o'clock in the afternoon and you have 100 users on your system. So what we want to do is look at some sort of mirroring capabilities. And how we're going to implement that mirroring is going to be really up to the DBA. Again, there are two ways of mirroring. We have high safety and we have synchronous. Well, even before we do that, we have different ways to implement mirroring. We have truly database mirroring, we have what's called replication, and then we also have what's called log shipping. The method that the high availability is going to be implemented will be up to the DBA. Mirroring just happens to be one of the methods that's available to the DBA to implement high availability solutions. If we look at the two types, we have high safety. High safety is dealing with synchronous writing. When we talk about high safety component of database mirroring, what we mean is that we will write to the primary and the secondary, and we will not end the transaction until we have successfully written to both locations. So if we have a database in one location and our mirror database in another location, until the transaction has successfully written to both locations, the transaction is not complete. Then we have high availability. High availability is dealing with asynchronous writing. When we talk about asynchronous writing, we're saying that we will write to destination A, and then we will try to write to destination B. If destination B is unavailable, that's fine, we will still continue the processing. What you'll need to understand, make a determination within your own organization, what type of method do you need to choose? First of all, you've chosen to use database mirroring. Within that, are we going to go with high safety or high availability? High safety basically means no data loss. I guarantee that if the primary site goes down, the secondary site will contain all the data. High availability says if the primary site goes down, I might have a minimal amount of data loss. And is that acceptable within your own organization? So exactly, high safety is used when no data loss is unacceptable. The transaction is not complete until written to both the principal and the mirror. In high availability, the transaction is complete when only written to the principal. Most useful when some data loss is acceptable in the event of some sort of natural disaster. So first of all, we've chosen to use database mirroring. Now this is a specific term used within SQL Server 2008. Once we choose database mirroring, we will then identify two components: the principal, which is the primary database, and the mirror, which is the secondary database. This is just the method that we have chosen to perform high availability within our database. Once we have chosen the principal and mirror, we will then select, is it going to be high safety or high availability? We also have what's called a witness server within database mirroring. A witness server is a server that is up and running that is effectively going to witness whether or not the principal is up and available. Now the witness is a total optional component within database mirroring. We have our principal in one location, our mirror in a different location, and our witness can be in a completely different location as well. The witness will periodically ping or look for a heartbeat of the principal. If it cannot find the heartbeat of the principal, it will automatically fail over to the mirror, thus making the mirror the new principal. It is totally optional. It is not required. If you do not have a witness server, then the failover would be performed manually. The products that will support database mirroring are SQL Server 2008 Standard Edition, SQL Server 2008 Enterprise Edition, as well as the Developer Edition. In order to implement database mirroring, the principal database must be in full recovery mode. The mirrored must be in no recovery mode. What effectively is happening here is the mirror is in that no recovery mode, and it's effectively receiving the log files from the principal. So as changes are being made to the principal, those changes are being sent over to the mirror. In the event of a failure, we can immediately fail over to the mirrored server. The steps to perform database mirroring. A, we back up the principal. Then, restore the principal to the mirror. So when we go through the restore process, we're going to restore the principal to that mirror. We're actually going to create the mirror from that principal. The backup from the principal must include all data files and all transaction log files. So what we've done here is we've identified our principal server, which is going to be Northwind. We'll go under Tasks. Under Tasks, we're going to select Backup. Then we can look at Database Properties. Under Database Properties, we can look at Mirror. We can identify the principal, the mirror, and the optional witness server. If we look at the operating mode, we can select, is this going to be high performance or high safety? We will come over here and we will also configure security. However, please understand that we have already performed the backup and the restore. So under Database Properties, right mouse click, then go to Mirroring. When we configure security, we go through the Configure Security wizard. Effectively, this is enabling mirroring. So we've already backed up our principal, restored it to our mirror, and now we're going to enable mirroring from our principal. It says, do you want us to include a witness server, yes or no? That is totally up to you whether or not you want to include the witness server. I think, although we have it flagged here, the default is yes. I think we actually selected no when we created the witness server on this machine. It says, do you want to save the security configuration in the following? Do you want to save it in the principal, the mirror, or here we've actually selected to install it to the witness? Effectively, what will happen when you create a principal and a mirror, it creates what's called an endpoint. For those of you that have done any sort of development work in Microsoft SQL Server, you would create an endpoint. That's exactly what we have here. We have a mirrored endpoint. So we're going to create an endpoint that's associated to our principal instance. The default port is going to be 5022, and we're going to give it a name, the endpoint name of mirroring. Also, encrypt the data sent through this endpoint. I'd recommend that we set this flag because that way the data will be secure. The next thing that you're going to do is set up your mirror instance. So we've set up our principal, now we set up our mirror. This mirror server is designed to be a completely different server. If the mirror server is the same server, you have to give it a different port. So now we're going to provide the service accounts for the principal, for the mirror, as well as optionally for the witness. These are the service accounts or the trusted domain accounts that will log in and send information between the principal and the mirror servers. Once we have set up our principal and our mirror, our principal is set up to listen on port 1522. Encryption is enabled. Our mirror server is on the same server. Now you'll notice the names here cannot be the same and they have to have different ports. So this is listener port 1524, this is listener port 1522. If the mirror and the principal are on the exact same machine, they have to have different ports. If they're on different machines, they can have the same port. At this point, we've configured our endpoint for our principal, we've configured our endpoint for our mirror. Now we have effectively started mirroring. The mirror will physically create endpoints, and we can start the mirroring right away. It's a relatively simple process to perform mirroring. The steps are: create a backup of the principal, restore the principal to the mirror site. At that point, go under database mirroring for the principal, create a new mirror, then identify the principal, identify the mirror, create the endpoints, and it will automatically start and create mirroring. The mirror database is a read-only copy. At this point in time, you cannot perform any inserts, updates, and deletes against the mirror. Be well aware that mirroring and snapshots are different. Mirroring is going to be up and running and receiving transactions from the principal, whereas a snapshot is just a picture of a window in time of the production database. A snapshot database is predominantly used to offload heavy reports from your production system. There is no failover capabilities with a snapshot. As a matter of fact, in a snapshot environment, if the primary goes away, so does the snapshot. As the transactions occur, they're automatically written to the mirror. The whole point for database mirroring is for high availability in the event of a disaster recovery. Database mirroring is designed for failover. It's not designed for any form of backup and recovery. It's not a backup and recovery solution. It is a disaster recovery solution. A lot of organizations, they might have 2 data centers in a particular city. They have their primary data center and they have their secondary data center. And this is where their database mirror would reside. Their database mirror would reside in the secondary data center. If the primary goes down, we can immediately fail over to our secondary. If you have a witness server involved, it will automatically take effect. If you do not have a witness server involved, it's a manual failover. On top of that, we also have what's called database clustering. Database clustering is designed for performance and throughput and general availability. So database mirroring is designed for primary and secondary, where clustering is for overall throughput. If I have multiple servers that are clustered together, if one server goes down, the other servers can automatically pick up the slack from that server that has failed. Database clustering is having additional services access the same database. It is designed for scalability. The thing that you need to understand is database clustering is not part of a disaster recovery model. Database mirroring, you have a primary and secondary in different geographical locations. With database clustering, we have a cluster or a server farm in our data center, which can handle additional throughput or additional users. So now, if one system goes down, the entire system is not down because it is a database cluster. Database clustering is part of a performance model and a throughput model. So if you are in a single instance environment where you have one system and you have 100 users accessing that system can be very well taxed. Now, if you're in a clustered environment and you have a 4-node cluster, you could have 50 users on each node. Now you could have 200 users accessing your system and not require additional or significant amount of system resources. Database clustering is all nodes are active and working. There's no primary or secondary node. So all nodes are working in conjunction in database clustering. There are 2 types of clustering. There's active-active and active-passive. Active-active is probably the most common. That means where all nodes in the cluster are up and working. Then we have active-passive, where active-passive is one node is active and the other one is passive. If the one node goes down, the passive node will automatically become the active node. With active-active, each node will work independent of another. The SQL Server instance is running on all nodes of the cluster. With active-passive, SQL Server instance is installed on all nodes within the cluster. However, only one node is actively running. When one node fails, the other node will automatically start and begin processing. Probably the most common is to have active-active clustering. There are some organizations that will choose active-passives for their own business needs. Again, you will have to determine what is best for your own organization. There is a big difference between SQL Server clustering and hardware or operating system clustering. I've worked with many organizations that they have chose to go with operating system clustering versus SQL Server clustering. And again, that has to do with their own organizational needs. Just need to understand the differences between the two. One is at the database level, the other one is at the operating system. Do you have any questions? If you have any questions, please feel free to use the question and comment box found below. Thanks for joining us.